Hello everyone. Sketch free body diagrams of the particular areas asked for as seen in figure 3. Label all relevant forces and angles. Part A is about the centre of the windmill, which is node A, which means that we are only interested in the forces acting on that central part of the windmill there. So we want to ignore the column holding the propeller up, which means the only forces acting on A, first of all, we're dealing with a node, so that point has no weight itself. The only forces are going to be due to the three blades. So first of all, let's draw in a line which is going to represent our vertical, and we are going to draw forces due to each blade. So that's the force due to the first blade, and then we've got a force due to the second blade, which is F2, and then there will be a force due to the third blade, which is going to be F3. And for each of those three forces, for recognizing those three forces exist, that's half a mark. But we also need to find some angles as well. So at the point of interest, the blade here, the top blade, makes an angle θ1 with the vertical. So that is going to be half a mark for recognizing that that is an angle that we need to know in order to find any forces if we had to do any calculations. The three blades are 120 degrees apart, which means that the angle here would be 120 degrees and 120 degrees, and there would be another 120 degree angle, but that third 120 degree angle we would not need to draw in. The last angle we don't need because we have already drawn in enough forces and angles that if we had to do the calculations, we could find everything. So these two 120 degrees angles will be a half a mark each. You don't necessarily need to say that they're 120 degrees, but you at least need to say that those angles need to be found in order to be able to, if we had to, do the calculations to find what F1, F2, and F3 are. Okay, and some of you would have rotated the windmill around a little bit so that the top blade is pointing exactly vertically, which would be fine as well. So if you've drawn F1 pointing exactly vertically, so that there would be no θ1 in your diagram, yep, that would be full marks for that as well. It also doesn't matter whether you've made F1, F2, and F3 point inwards or point outwards. So if they've been made to point outwards, then you're still getting full marks. It's just that if you were to calculate F1, F2, and F3, that would affect the sign that you're getting for your answers, but you've stated that there are forces acting along each blade, which is all that we need here. And question B, we have a gantry crane, and we are only interested in forces acting on B and C. So this is point B, and this is point C. Now we will have the weight acting straight downwards, so that is going to be F1. That's the weight force it's acting in the middle, and at B and C. So there's a post at B which is supporting the weight, so it's holding up BC as well, so that's providing an upwards force which is F2, and same thing at C, there's a post providing an upwards force on BC, so that will be F3 there. So far that would be half a mark for each of those. So half a mark for F1, F2, and F3. And we also need to recognize that there's some pieces of cross bracing in the diagram. So cross bracing at those two ends, so at B and at C. So that is also going to support the beam. So we've got another force pointing in that direction, which is going to be F4. and there is another force acting in this direction going to be F5, and those make angles. So this is going to be theta 1, and this is going to be theta 2. So we need to state those angles, and for marks for the cross bracing, half a mark for drawing in F4, half a mark for drawing in F5, and again, the direction of the force isn't so important. What's most important is that you've recognized that there is a force acting there. And there's also the final half mark is going to come from both angles. So if you've drawn both angles, so the angle here and the angle there and the angle there, or if you've drawn the angle with the posts as well, that's a possible. Instead of drawing theta 1 and theta 2 with the horizontal, you can draw those two forces with the vertical as well. And so drawing in both forces, so both theta 1 and theta 2, would be the final half mark. So if you've only drawn in theta 1 or only drawn in theta 2, you don't get that half mark. Thanks for watching.